Hello, we are the team named Mex, and we are going to introduce you to our final challenge. The purpose of this activity is to perform a task that is carried out daily in the current industry, which is the execution of a pick and place operation with a piece. The pick and place operation was performed using the model robot P1 and the X-arm robotic arm. The pick and place process involves the robot moving to the table to pick up the piece with the robotic arm, then moving to the other side of the table to place the piece, and finally having the mobile robot return to its initial position. In order to deliver a successful project, we adopted a waterfall methodology. We began by designing the fixture and the piece to be gripped. Following that, we proceed to implement the control for the movement of the robot V1. Afterwards, we defined the motion patterns and finally executed the movements of the X-arm at each required point.
We decide to pick a 3D printed cylinder in order to get a better adjustment to the gripper. The cylinder is 8 centimeters high and 4 centimeters in diameter. Additionally, we manufactured the fixtures where the cylinder was going to be picked up and placed it, using plywood as our raw material. To obtain the following code, we create the block program in the UFactory program. In this case, we use movejoin to record the coordinates of the X-arm, showing in orange, and also to send a signal using set digital output. In this case, it's 0, to open or close the gripper. Finally, we send a signal in Python to the terminal for the V1's path to initiate the X-arm movement.
In general, the proportional controller, only with proportional, tends to experience constant errors in the steady state, difference between the desired value and the actual value, unless a high control gain is used. However, as the control gain is increased, problems related to feedback system stability may arise. In our application, proportional control was sufficient since it was small, and the pick and place operation was performed with acceptable accuracy, meaning it could pick up the piece and place it in the correct position.
Initially, we can observe how our mobile robot starts from an initial position and it must reach the first target, which will be the first table. At this table, the X-arm will perform the pick operation on the cylinder. Once the X-arm has the cylinder securely held, the mobile robot will continue along the path around the station until it reaches the second target, which will be a second table. Here, the X-arm will be responsible for performing the placement of the cylinder inside the second manufactured fixture. Once the X-arm finishes placing the cylinder, the mobile robot will need to return to its initial position, circling the station again, and marking the end of the program sequence. It's important to mention that we had to manually position the fixtures near the robot because we were working simultaneously with other teams, which caused the tables to be constantly misaligned, affecting the stored positions in our code.
Initially, we divided the programming task for both robots, the Dash V1 and the XARM robot, among our team members. Half of the team focused on programming the XARM robot, while the other half worked on programming the Dash V1. Subsequently, we created a script within the Ubuntu software to integrate both sets of programming. We conducted simulations using the P control method to validate our approach before implementing it on the physical robots.
In summary, our pay controller experienced an error accumulation, leading to phase shifts in the robot's movements during startup. Furthermore, the presence of other students in the laboratory rearranging tables create challenge when attempting to return to our original position, affecting precision. While our robot's current behavior is acceptable, there is room for improvement. Unfortunately, we face limitations due to time constraints for real simulations and the availability of operational robots with only two functioning effectively. The advantage of our chosen control method lies in the ease of implementation and inherent robustness, typically surpassing P controllers in stability. Nonetheless, there are notable disadvantages, including the issue of phase shift in the robot's movements, resulting in less precise positioning. This control approach is inherently less precise than a payday control, which excels in situations where minimizing error is critical.
This activity helped us reinforce our understanding of Python and its connection to ROS. Our system faced challenge due to a controller error and issues with table placement, causing disorganization and synchronization problems in our pick and place operation. We also encountered difficulties with V1 and V4 when using a larger battery to operate the X-arm, resulting in further synchronization issues. Additionally, working with different robots on different days required repeat X-arm reconfiguration. We had to record the video in segments due to time constraints, only 2 hours of work per day, and the maintenance challenge, but all the necessary steps are documented in the code.